and it's the most interesting subject. It is demystifying security. I guess I should probably start with a safe harbor saying that I'm not an expert in security, and the objective of this conversation, the next few slides, is to essentially share with you what you need to be thinking about from end-to-end security perspective when you're building mobile applications with the Couchbase platform. So I'm going to talk about a few things in this session. The number one thing is like, what are the security concerns that you should be worried about? And then how are you going to secure data at rest, especially in the mobile scenario when you've got like local storage on the device? Securing data in motion, how you do that in the context of Couchbase. Authentication, what authentication mechanisms are supported by Couchbase today? And then I'm going to talk a little bit about the data access control mechanisms available in Couchbase as well. And then I'll leave you with a few resources that you could go check out after that. And we can continue the conversation from there. So typical three-tiered architecture application would look something like this, where you have a client here that is talking to a bunch of web services or application servers that are hosted in your middle tier over the internet. And then the application server would essentially connect to the data tier. In this case, the data tier happens to have a database that's going to be basically communicating over the intranet. So this is like, I think from a level set perspective, the most generic three-tiered architecture that we could come up with. And when we think about an architecture like this, I think the key security concerns to think about are, like, if you're storing data on the device, how are you encrypting data on the device? What's the file system encryption? What's the actual data encryption, if you will? How do you rotate keys on how data is being rotated? And then what sort of offline login support do you have today? On the wire, you want to make sure that you're using TLS and the communication is secure. From an authentication perspective, you want to know who the user is and then what's the security session for that user. Data access control, you want to make sure you have the correct read access for all of your data. And then you have write validation. So if I'm trying to write a record, am I allowed to write a record? How do you essentially make sure of that? And then last but not the least, like the data storage in the cloud. I think when you have data stored, then again, this is the whole notion of like, how is the communication happening out there, and then what's the data encryption at rest all about? In terms of mapping this to the three-tiered architecture that I just brought up in the previous slide, so I'm going to start at the extreme left. So the first thing on the left-hand side is local storage. So if you have a client application that is storing data locally, how are you going to secure that data? When that client application is communicating with your middle tier, which is number 2 over here, which is the whole transport piece, how would you secure that data? And again, on the transport piece, there's also communication between the middle tier and the data tier, which typically would happen over the internet. How would your security of that communication be handled? Then on the middle tier, there's a couple of interesting things. The first one is when you're logging into the application servers, you need to authenticate yourself. The application server needs to know who it is. If it is Sachin, then what sort of permissions does Sachin have? What data can he access, and what data can he not access? What data can he write, and what are the things that he doesn't have access to write to? And then, but last but not the least, number 5 out there is how you have data stored in the cloud. So you've got all of this data that's going into a centralized location or a central server in the cloud. That is one other thing that you've got to be concerned about. So if I think about it, I think let me address how Couchbase addresses security concerns across the full database stack, if you will. So on the first one over there, which is local storage, for Couchbase Lite, we have full database encryption, which is AES 256. For communication between Couchbase Lite instances to the middle tier, which is the sync gateway, and for communication between the middle tier and the data tier, we have secure transport over the wire. We support TLS. On the middle tier, we have the sync gateway, which essentially supports pluggable authentication. And there is user and role-based data access control over there. And then last but not the least, we have secure data storage in the cloud on the Couchbase server side, where we partner with the best of breed security vendors to create a solution for you. So what I'm going to do over the next few slides is essentially go through each of these and what Couchbase does on each of, for addressing security concerns on each of these tiers, if you will. So let me start with the local database storage. As I've mentioned out here, we've got like full database encryption, which means that documents that are stored in Couchbase can be encrypted with fairly strong keys and an AES 256 algorithm. What this means in terms of securing local storage. So let me think about it from an application developer's perspective and take a step back and figure out how you interact with a typical application, and then where does secure data storage come in. The first step, if you're using any app today, and I think I took this off one of the popular apps out there, was you're either asked to authenticate yourself with a user ID or a password, or you're asked to essentially authenticate yourself with your fingerprint. Once you're authenticated with the application, I'm not going to go into how you would do that, and there's like different ways of doing it. The easiest way, I think, on an Apple device, if you're using fingerprint, would be to store the fingerprint, essentially authenticate yourself with the fingerprint to access the keychain of the application, and then get the key from there. But to get to the data that is stored on the local device, you need the key to be able to decrypt the data. So that's something that you've got to think about. And once you have the key, you can decrypt the data, then your application starts to function the way it is supposed to be functioning. So I've just used the example of the To-Do Light application that we have and essentially come up with like a scenario where you're authenticating yourself, then you're getting access to the key, and then after getting access to the key, you're essentially able to decrypt the data, and that's when you start seeing how your application is configured to work. So what's really happening out here is that there's a whole bunch of work that is being done. Some of this work is done by Couchbase out of the box, and some work needs to be done by an application developer because it's an application developer concern. So Couchbase provides full database encryption. As when you turn on encryption, we make sure that all the database files are tagged appropriately so that the file system encryption is turned on as well. And then from a key rotation perspective, it's very easy to rotate key. Couchbase has APIs that allow you to change the database encryption key as well. So you can think of a scenario where your application password change, and if your key was based on your password, then you would want to be able to essentially move from the old key to a new key which is based on a new password. So we give you mechanisms to essentially put in your old password, move all of the data over, and then re-encrypt the data using the new password. And then last but not the least, offline login. So offline login is like a separate topic in itself. I think there's like various approaches possible. I think in the last slide, like I mentioned, you could have a username password-based approach, or you could have an approach where you're accessing yourself or authenticating yourself using a fingerprint for offline access. From an application developer perspective, you've got to take care of key storage, and also how you're going to be selecting keys. So those are things that you have to worry about, and those are things that are application level concerns. That's the local storage. Going back to the overall stack diagram, let me talk about how you're going to secure transport. And transport is two aspects, one over the internet and the one over the intranet. So from an internet perspective, essentially this is Couchbase Lite communicating with the sync gateway, and you want to make sure that that communication is secure. So the way to do this is I showed you an example of what the code looks like in like my previous session with a live demo. But if you notice the sync gateway URL out here, you'll notice that it's a secure URL. It's HTTPS as opposed to being plain HTTP out here on the code sample. So the way to essentially use secure communication with Couchbase Lite from all the way to sync gateway is to use an HTTPS-based sync gateway URL and configure sync gateway appropriately. To configure the sync gateway, you actually have to specify the the certificates in the sync gateway configuration API, so that sync gateway knows how it's going to actually encrypt and decrypt the communication. This is, again, transport over the internet. The other aspect of this is essentially transport over the intranet, where the sync gateway is going to be communicating with the Couchbase server. Again, the sync gateway configuration file has the URL of the Couchbase server that's going to connect to. And if you change that URL from HTTP to HTTPS, then that's like the simplest way to make sure that your communication is secure. So as you can see, Couchbase, with the out-of-the-box capabilities that we have, makes it really, really easy to switch between, in development, plain HTTP communication, and when you actually move into production, to secure HTTP communication. Again, on the sync gateway side, there's two aspects of security. The first one is authentication, and the authentication is pluggable. I'd like to go into a little bit more detail over here. So the first one is basic authentication. We also support, again, basic auth has been used by our customers in some cases, but I wouldn't say is the most secure option, even if you're encrypting your communication. OpenID Connect is something that we support, and it essentially extends the OAuth 2 protocol for authentication. For customers who don't have OpenID Connect deployments, we support a custom authentication mechanism where you can actually customize the sync gateway authentication mechanism as for your needs. And then last but not the least, if some of you are trying out building consumer-facing applications, we also support the Facebook login. So in this talk, I'm going to talk a little bit more about what you can do with OpenID Connect and with custom authentication. So OpenID Connect is an interoperable authentication protocol. It's a simple identity layer that's built on top of OAuth 2.0. If you're not familiar with OAuth 2.0, it's like a bunch of mechanisms that are defined to obtain an access token, actually obtain and use an access token, and be able to access protected resources. But there's no standard method to provide any sort of identification information. So OpenID Connect extends OpenID Connect is a protocol that extends the OAuth 2 specification and allows for the access to the user's identity, basic profile information about the user. There are multiple flows in OpenID Connect, and the supported flows from out of the box from Couchbase Sync Gateway are the authorization code flow and the implicit flow. I'm going to go into details of what both of these mean. I think from a deployment perspective, a couple of companies or a few companies that have OAuth deployed or have solutions for OAuth or have production deployments of OpenID Connect, are Google, Microsoft, and Ping Identity. And there's a few more as well, but I just wanted to throw it out there to let you know that there are quite a few companies that are betting seriously on OpenID Connect. So this slide actually is a fairly detailed slide, but it captures the end-to-end flow on what happens with the authorization code flow with with OpenID Connect. The actors in the system are essentially a mobile device, and then in this case I've called out even on the mobile device there's a system browser, which then interacts with the sync gateway, and there's an OpenID Connect provider, and then there is an identity provider. So these are all the various entities in the ecosystem, if you will. The application essentially initiates authentication by connecting to the sync gateway's OIDC endpoint. From there, the sync gateway redirects the application to an OIDC provider, and then the device opens the OIDC endpoint essentially opens the endpoint in a system browser. Again, I think the browser pop-ups is the preferred way for web apps to redirect the user to the IDP. Mobile apps on like iOS or Android should launch the system browser as opposed to using embedded web views, because the system browser is trusted, and with the embedded web views, you can have scenarios where the application is snooping on your secure password or on your communication. So from there, the user is sent to the OIDC provider's endpoint via the system browser. And then there's a challenge for user authentication, which is completely opaque to the application, and then receives the credentials, which goes back to the identity provider, validates the credentials, and then upon the successful authentication, it redirects to the sync gateway with an authorization code. The end user is, and this is all happening in the browser, in the mobile browser at this point. And then from there, the end user is redirected to the sync gateway with the authorization code. The sync gateway uses the authorization code to request a token from the OpenID Connect provider. The OID provider returns an access token, a refresh token and an ID token to the sync gateway. Sync gateway essentially creates a session for the authenticated user. And once the sync gateway session is created, it returns that session ID to the with the ID token and the refresh token to the system browser. From where the system browser then makes that information available within the app. The app essentially sets that on the replication headers, and then whenever the replication is happening between Couchbase Lite and sync gateway, the authentication cookie is being set, so that there's a security session that is context that is set for the sync gateway or for this particular user to be able to access the sync gateway. So again, this is fairly detailed and fairly involved, but it's I think my view at simplifying or trying to demystify what's happening under the hoods when you're actually authenticating with sync gateway. The other one that we have that we support today is the implicit flow with OpenID Connect. So again, this is a slightly different flavor of the flow where the user essentially gets authenticated with the OpenID Connect provider, gets a token, and then essentially accesses the sync gateway with that token. So if you look at the first few steps over there, the application again initiates the authentication and opens up the system browser, is redirected to the OIDC provider. There is a challenge for authentication. The user enters their credentials. The credentials are validated at the backend in the identity provider, and then the client receives a token in the response. Couchbase Lite uses that JOT token. JOT is the Java Web Token that is the ID token in OpenID Connect, and gets a sync gateway session from there. Sync gateway would allow you to create a user based on that JOT session, and then sync gateway session cookies return back to Couchbase Lite. That session cookie is again set into the replication headers, which means that when any replication is happening subsequently between sync gateway and Couchbase Lite and sync gateway, that is happening over a secure channel, rather, or via the in the context of the authenticated user, for which the session cookie was set. Now, for customers who don't have an OpenID Connect provider, we also support the custom authentication mechanism. This is a slightly different flavor. So again, to keep it simple, I've changed the parties involved over here. Again, the mobile device, then there is a custom authentication provider, which is what you might have deployed in your enterprise. There's an identity provider, and then there is a sync gateway. So the application initiates the authentication with the custom auth provider. There is request for credentials where the application directly interacts with the custom auth provider to provide those credentials, gets the credentials, they're validated with the identity provider, and upon successful validation, the custom auth provider would create a user on sync gateway using the admin REST API. And then it would essentially post the request with the username that was of a newly created user. If the user already exists, then they just directly go to the REST API and create a session for them. And then there is a session authentication cookie that is set. And then the cookie value for the sync gateway is set in the response body also. And then that cookie is returned back to the client. And then the same cookie is again set in the replication headers, which is why when Couchbase Lite then replicates subsequently with sync gateway, the authentication context of the user is then made available. So that's the pluggable authentication that exists within sync gateway. I'm sure it's a lot of information to consume, and we'll be putting up these slides on the web so that you have access to these flows as well. I'm going to talk a little bit about how user and role-based access control works with Couchbase Mobile. So before I do that, let me just take an example again of the to-do app that we have and just talk to you a little bit about the requirements from an access perspective. Sure. So in some cases, the IDP and the custom auth provider might be the same, but there may be situations where the identity provider and the auth provider might be different. So the IDP is the authenticator, which is the profiles or the username and password, which is going to validate the credentials. But the auth provider might be different. Again, this is just a representative, I think, scenario. The exact scenario would be specific to your organization. Sure. All right, let me go into the user and the data access in mobile apps. So this is the to-do application where I've got a user, Bob, who's essentially got a list of groceries, my favorite example. And then he also is an avid outdoors person, has a camping trip planned. Now, as far as groceries are concerned, Bob would like to share that with Alice, who happens to be his roommate. And the camping trip, Bob is planning with another friend of his, which is John. So if you think about it, there's like a whole bunch of nuances of being able to do something like this, where Bob's sharing his groceries with Alice, has a different container for essentially his camping trip, is able to group all the tasks related to a camping trip out there, and is sharing those with John. And then again, the requirement there again also is that Bob is the only one who can actually mark any task as complete. So while he's sharing the list with Alice and sharing it with John, Bob's the one who's on the hook to essentially get these things figured out. And once he figures these out, he can actually go ahead and mark them as complete so that Alice and John know that these have been done. So what does this really mean from an application developer perspective? So let me just try and talk about that. So the first thing is you want user-based access. So Bob is the one who's creating all of the data, but then Bob is sharing some things with Alice and some things with John. You want to know what role you are in. So Bob is the owner, and Alice is somebody who's just viewing stuff that Bob's created with her. And the same is true for John. So Bob's still the owner, and Alice is somebody who's actually viewing stuff that Bob's created. Data partitioning. So Bob would like to have two lists, one to share with Alice and another one to share with John. So that's like stuff that you absolutely need from a data modeling and data access perspective. Read access. Both Alice and John only have read access to the data that they've gotten. Only Bob can mark a task as complete, so you absolutely need that. And then in many cases, write access. Like you've got to make sure that you have the right permissions whenever you're writing data, and then anytime you're writing data, you probably have some needs in validating data to make sure that it conforms to a certain format or it's meeting certain requirements depending on whatever your business logic is. How does Couchbase address all of these? For user-based access, we have user permissions, so you can actually define permissions at a really fine-grained level. We have APIs for role definition and assignment, so there's this whole notion of being able to not only define a role, but also assign it using the APIs. We have the concept of channels, which is essentially a way of partitioning data amongst different parties. You can provide access grants. So with access grants, you're able to provide read access to the data. In some cases, you might want to have like write access available. So that is done via a sync function, which is essentially your way of customizing the Couchbase mobile deployment or the Couchbase sync gateway for the needs of your business. And data validation, again, is something that you can do via the sync gateway. So again, this is at a very high level, thinking about the various needs from a security perspective when you're thinking about like a simple application like the to-do app, and then putting them in here and talking about constructs that exist within Couchbase that allow you to essentially meet the requirements from a security perspective. So again, I'm not going into details over here. There's a whole bunch of, I think, material available on our website, even in our tutorial app, on how you would do something like this. But at a high level, these are the concepts that you'd want to be thinking about when you're thinking about mobile security. So now that I've covered the first four, the last part that I definitely want to cover is like, how do we secure data at rest in the cloud, which is on the Couchbase server side. So again, we partner with the best of breed partners, and then you can have security that is defined at a coarse grain level, which means that your whole file or your volume for the database is encrypted, or you could define that at a field or a column level. So again, I'm not going to go into details over here. In fact, one of my colleagues in one of the other tracks, which I'm sure will be streamed live, or rather will be available pretty soon, has talked in detail about what options are available on the server side as well. But I think the key message from my perspective here is that with Couchbase, you can address the security concerns across the full stack, right from how you're storing data locally to how that data is being transported, whether on the intranet or the internet, the authentication mechanism that you'd like to build for your enterprise, and then be able to provide fine-grained access control for users as well as for data. Last but not the least, we secure data at rest on the in the cloud as well. And I have a few resources over here that'll be available when this presentation gets uploaded on the web. There's a couple of blog posts that I've got over here. One is from Wayne Carter, who's our chief architect for mobile, where he talks about security at a very high level and what you'd like to be thinking about from a security perspective. And then there's one from one of our developer advocates, Hart Greeley, on OpenID Connect and Couchbase. With that, I'd like to thank you for your time and happy to answer any questions. I was hoping you would ask that question now. But yes, I think, so that is something that we're working on right now. Right now, the two are kind of independent. And as you can imagine, I think the types of users that the Sync Gateway handles are very different from the types of users that Couchbase Server handles. So on the server side, it's an application tier user, or as an application persona, I'm actually accessing the server as an application on behalf of a user. But on the Sync Gateway side, I'm actually coming in as a user itself. So as you can imagine, the roles out there would be very, very different. So those are different right now.
Are the permissions defined by Couchbase, like read and write at a specific level within the document, or can we define our own permissions as needed by the application?
You can define your own permissions as needed by the applications. If you have a whole bunch of flexibility with the tagging concepts and the concept of channels that you have within Couchbase, and with the flexibility that is provided in the sync function, you could essentially put in your own access grants. So you don't have to be dependent on how we think about the various permissions. You can put in your own fine-grained permissions in there. Cool. Well, if there are no more questions, thank you very much for joining us here today at Couchbase Connect in New York. On behalf of the rest of the Couchbase team that is now sitting in this corner, I'd like to invite you to come join us for the happy hour. Yes. We'll be having a happy hour somewhere here. Thank you again.